続きまして
We would now like to move on to the keynote speech from Playground Global founder and CEO. We have with us Mr. Andy Rubin. He will talk to us on the topic of the marriage of robotics and artificial intelligence.
Hello, everyone. How are you? Good, good. Well, I'm super excited. I have a lot of stuff to talk about. They've given me a little bit extra time. And at the end, we're going to have a little Q&A session. So if anybody wants to ask some questions, feel free to ask some questions. It can be pretty much on any topic. It can be on Android, which I think everybody knows is one of my past projects. Or it can be on robotics, which is the main topic of this speech. But, you know, having founded Android, I spent a lot of time thinking about what a platform is and what a platform means and the network effects of developing a platform and then having other companies bet their whole careers on building applications and things on top of the platform that I created. So these ecosystems that show up pretty much every couple of years are really, really important, and I'm going to spend some time talking about that a little later, okay? So even though we're talking about robotics and AI, we're really talking about platforms. And one of the platforms that I created after I left Google was Playground Global. And what it is, it's a new type of venture capital investment firm, and it was basically, we arrived at the idea because after Google and after Android, I was thinking about what I was going to do for the rest of my career. I'm fairly young. I still have a lot of energy. I want to do more things. I want to make the world a better place with technology. And I spent a lot of time thinking about, well, how can I ever create another company that's bigger than Android? It seems impossible because Android was so successful. So I don't want to call it a midlife crisis, but I thought very, very hard about what the next thing I was going to do would be. And what I decided is it wouldn't be just one thing. I wasn't just going to go and create another company that would hopefully be bigger than Android. Instead, I created a structure that allows me to do 10 or 20 things at once. And that's what Playground Global is. So I became an investor. I raised a venture capital fund of about $300 million US. A lot of famous partners backed me in raising that capital. But I did something different. I didn't want to be just a venture capitalist. So I built an engineering organization within the venture capital organization. And it's kind of like mashing up a venture capital firm and IDEO, a product design firm. This venture capital firm has 50 employees who are the best of engineers, from mechanical engineers to industrial designers to software engineers, you know, RF engineers, everything. And what these guys do, when the venture capital firm makes an investment, the engineers sit side by side with the entrepreneurs that we just invested in, and they help them build their product. They sweat the details of product design alongside the entrepreneurs that we invested in. And the hope is that we're gonna create less risk as an investor because we guarantee that it's our engineers helping these companies be successful. And it's new. It's been only about 11 and a half months, so it's less than a year still. I can still say that. And we're certainly learning a lot, but so far it looks pretty interesting. So check out the website, playground.global, because we view ourselves as a global effort to do this. Similar to what Peter said, it takes more than just one company to be successful. Peter was talking about the open source movement. Obviously, that's a community effort. There's a lot of people that are kind of moving technology in a direction, and it's a lot easier if you have collaborative partners to move technology forward. Think of yourself as a surfer in the middle of the ocean. And you could be on your surfboard paddling in the ocean trying to make a wave, right? Or your timing can be right and you can ride the big wave all the way to shore. Which would you rather be, the guy alone paddling, or the guy with all the other surfers that catches a big wave and rides all the way to shore? Okay, so talking about platforms a little bit. So I have a thesis, and part of the thesis of Playground, my firm, is that new computing platforms happen every 12 to 15 years. 10 to 15 years, 12 to 15 years, it's not precise. Nobody really knows why they happen. But if you look at history, at least back to things like MS-DOS and Windows and Macintosh and the internet and mobile, each one happened about 10 to 12 years apart. And what's more interesting is each one got bigger as it went along, and they also fed off of each other. So Windows and Macintosh relied on a DOS operating system to be successful. And the internet needed windowing systems and graphical user interfaces to be successful. And mobile, well, the killer app on mobile was the internet. They just cut the wires and allowed you to take the internet with you on your cell phone. So all of these platform ecosystems that evolve go in phases, they build off of each other, and they get bigger and bigger as more and more of the world starts using them. So we started thinking, it's really hard to predict when Bill Gates wrote MS-DOS. The industry didn't need an operating system when he wrote it. But he wrote it because he had a passion for building operating system software. He did it almost as a hobby and saw a little bit of a business opportunity. But then IBM wanted to announce a PC and launch a PC, and they needed an operating system. So IBM went shopping, and they met Bill Gates, and boom, MS-DOS was part of every PC as a standard. And those things happen randomly. A lot of the times it's purely based on timing. It's really strange how important timing is. So if you can't predict what the next computing platform is going to be, how do you position yourself in the best place so you can take advantage of it when the timing is right and when it happens? So question for the audience, and I know this is after lunch, so you guys should, I'm really hyped here and I have a lot of stuff to talk about. So tell me what you think the next big computing platform is going to be after mobile. Anybody want to shout something out? Is it going to be just more phones and we're going to saturate and mobile's going to be the last platform ever? We're going to die as a human race. We're going to die with our phones in our hands, and that's the last thing we ever did in technology? VR. I think I heard VR. Virtual reality. And there's a companion to that, which is augmented reality. AI is another one. And I think they're both right. It's kind of, if you squint from this angle, you can see a lot of success building up in both of those, but they're relatively unproven. I think VR is less proven than AI, but interestingly, both VR and AI have been tried before. For the past 20 years, we've been trying to do AI. And for the past 20 years, people have been putting stuff on their faces and trying to make it work for various purposes. But maybe the timing's right. Maybe the timing's right for this stuff. So my thesis is, I think VR is kind of an extension to computing platforms. It's more like a 0.5. It's in between these cycles. And if you'll notice, these cycles overlap. So they're not standalone. They overlap a little bit. As one is dying off, the other one is coming to life. I think the next one is AI. And obviously, I've had insight into, having spent 10 years at Google, into some of the things that go on when you have data centers full of computers. And what those computers are doing on a normal basis, at a company like Facebook, it's making the social network work. At a company like Google, it's making search work, right? But what could those computers do as the companies grow up and as the companies have billions of users? What other things could those computers do? And some of the early experimentation, and you've all seen it in machine learning and computer vision, all those things are starting to get pretty interesting. Google just beat the best Go player with their AlphaGo. The DeepMind team at Google beat the best Go players with AlphaGo. So AI today, I think, is just at the beginning, but should the timing work out and everything kind of go flawlessly, it could be bigger than mobile and internet and everything else. So let's talk about that a little bit. How do you make AI big? What does it take? And how do we know when the timing is perfect? Well, I think if it's really big as I think it could be, we're talking about the next industrial revolution. It's bigger than computing, and it'll change the world in really, really significant ways. All positive, please. I think if you view everything that's been happening in the cloud, AI's natural home is in the cloud. That's the brain that's going to basically accumulate a lot of data, and I'm talking about a lot of data, and then it's going to make decisions on that data, and it's going to act on that data. Initially, like what we have today, the AI platforms in the cloud are very, very good at pattern matching. They can look at a Go playing board, and they can make decisions based on the visual representation of the little black and white pieces on the board. In the future, they're going to actually make bigger decisions than just pattern matching. And that's purely based on the amount of data we feed it. It learns, just like you and me, just like a 3-year-old learns not to spill a glass of milk. AI works the same way. Now, the problem is, if we leave AI in the cloud, it's trapped. It's like a brain in a jar. The only thing it can ever do is get all of its data from the cloud, and then its decisions or its pattern matching can only be put back into the cloud, right? So it really is in a virtual world, living in a virtual world. But what if we brought it into the real world? What if AI could sense everything that you and I sense? What if it could smell and hear and see like you and I see, and not just seeing things in a research environment, but what if it could get out in the real world and move about like you and I do? Then what does AI become? And this is the title of the presentation. This is the marriage of the pattern matching AI and the deep learning that we have today with the stuff that's coming out of the research labs, the robots, and everything else that's going to move around in the environment and work alongside of all of us. So what is a robot? You know, in the classic definition of a robot, it's something that gathers information. It has sensors to gather information. It creates a world model using that data to figure out what its next move is going to be. And then it acts on that next move. It actually takes action based on what it figured out from the data. So in the classic definition of a robot, a rice cooker is a robot. It senses the temperature of the water, brings it up to the proper temperature to cook rice. It has a notion of time, so it knows how far along it is and when it's going to be done, and then it alerts the user by beeping or playing a melody that the rice is done. The rice cooker is a classic definition of a robot. We used to do this by hand. We used to boil water, steam it, and it was imprecise. We always didn't get good rice out of it, but the rice cooker gave us very, very good rice and very quickly. Another example is a dishwasher. We used to, after dinner, we all used to manually wash our dishes and put them and dry them and put them away, but now there's a machine for that. We put dishes in a machine, they're dirty, and when the machine is done, they come out clean. And we didn't know anything about temperature or where the dirt went or the water or the time. The machine took care of that. So these are all classic definitions of a robot. So it senses the environment, it plans something based on that data, and then it acts on it. So if you have a robot, and the robot has wireless capabilities, and it connects to the cloud, and the AI is in the cloud, we could get to the point where the AI gets smarter and smarter. And it exists today. This is a Google self-driving car, and it senses the environment. It uses a laser scanner to scan the roads. It builds maps. It sees other cars, and it uses all that information to get you to the next place without any, in total safety. So this is already happening, and this is probably going to be one of the biggest robots you'll ever occupy. You sit in this thing, and it takes you where you want to go, using the sense, plan, act methodology. But what's it going to look like in the future? Self-driving cars are great. It's going to make my life a lot easier because there's a lot of traffic in Silicon Valley, and I can do other things while I'm getting to work. But what does tomorrow look like? So let's show a quick little video of a research project that happened at Boston Dynamics recently. A lot of you might have seen this on YouTube or something. The next generation biped robot here has been told to go get a box in the lobby of the building and bring the box to a desk in the back of the building. So he's autonomously navigating. You'll see the people with the laptops behind him. They're monitoring his systems. This is all research. He finds the box. He bends over, picks up the box. And now he's added that 10-pound weight to his whole dynamic profile. So not only does he know about himself, but he knows about the box as well. And while he's walking, you'll notice that box is hitting his knees as he's walking. And he's still doing fine because he's added it to his dynamic profile. And now he's continuing back. He knows exactly where to go because you'll see where his head is a laser sensor. And that has built a map of a building. And he knows exactly where the desk is in the building. Could be a she, doesn't have to be a he. I'm not sure. And there's the goal. You'll see the marker on the empty spot on the desk. Bumps into the desk by accident, and then backs up, and finally delivers the box. So, how many of you want to see something on stage other than me? So here's the problem. These demos never ever work. And they never work because stage lights are really bright, and there's like a whole bunch of infrared being generated by these guys back here, and you all have your cell phones and your laptops messing up the wireless spectrum. So it's probably not going to work, but at least we wanted to try, because you learn when things don't work, and next time, chances are it'll work. So we're going to try something really unusual here. We're going to bring a couple of folks that I worked with in my past out on stage. There's a Japanese company called Shaft that was acquired by Google, and they've been working in secret for a long time, and they've agreed to come on stage and present one of their latest inventions. So I want to introduce Yuto Nakanishi and his team Shaft. He's going to come out, and he's going to give us a good demo.
Andy さん、ご紹介。
Andy, thank you for the introduction. How do you do? My name is Nakanishi. I used to be the CEO of Shaft, and now I'm the manager of the Tokyo team involved in this project. And we have Shaft started as a startup company for robots, and then became part of Google. And Google Eggs is the organization we have been added to, and we continue to have a human-sized walking robot, and we're trying to make it more and more useful. Now, as for a biped walking robot, the first thing that we strive to achieve was the DARPA Audix challenge. This was a competition, and we'd like to show you some videos of this. This competition involves disaster response by robots. So there's a competition on this. As you can see from the visuals here, they climb ladders, they try to eliminate obstacles, and so on. these are the issues that these robots must tackle. This is to open a door. And here, a hole must be opened up in the wall. Close the valve. Finally, it's necessary to connect the hose. Thank you very much for viewing this. In regard to what you just saw, a DARPA robotics challenge, we finished this and we decided to make use of our biped technology for robots. And so we had to make human-sized robots which use less energy and less weight. So we would like to introduce the latest robot prototype.
So,
first let me show you the newest image of this robot on stage. So this first clip is the robot moving around the stadium. There are many steps. So you can see how the robot is maneuvering his or her way through the steps. This is showing you a clip of the robot carrying weight. This is a 60-kilogram weight. Now this, the robot is stepping on the pipe, however, the balance of the robot is maintained.
Now
next, this clip is showing the robot traveling through a very narrow space. Now next, you are seeing a demo where the robot is maneuvering his or her way the steps and also cleaning the steps. Now, not just in human residential areas, but the robot is now walking through nature. So soil is soft, and also at the same time it can be slippery. So there is an added complication. Now the robot is walking on rocks at the beach. And again, the robot is managed to clear this very bumpy terrain on the beach. Now the last image, the robot traveling on snow, and again has conquered the slippery snow terrain. Thank you very much for that. Thank you very much for joining me in watching the video. So let me show you on stage some of the newest movements of the prototype robot. We show on the video the robot walking through many conditions, and we are aiming to realize this, and at the same time we want to offer smaller space as well as a lower cost and lower power consumption, and we have focused on hardware and software developments to attain this. Now this robot only has legs, as you can see, but we have focused on the mobility and also this walking feature of the robot. Now, the length of the legs are adequate to accommodate human living conditions. So again, as you saw in the image, this robot can overcome steps and also step over pitfalls as well, can walk through very narrow areas. So if a human can travel or walk, then this robot has the potential to clear that as well. So again, leveraging this mobility, we believe that this robot can accommodate many conditions, as you saw in the image. For instance, it can carry weight, or it can work as a robot cleaner. If we attach robot arms, then we can further have the robot do more complex movements. There are many future developments that need to take place, but we would like to focus on this development and hopefully launch this and have society use this for the betterment of entire society. So thank you very much, and we look forward to collaborating with you. Thank you.
Congratulations.
Thank you.
There's a whole team in the back there monitoring everything, and they did a great job. So, what'd you guys think? Was that cool? So, this one is a casualty of the Wi-Fi network. We've had the robot. We brought it in from the US. It's the first time it's ever been out of America. And we've been practicing. We had 2 practice sessions here, but we couldn't get the controller to connect to the robot backstage here. It was supposed to come out with great fanfare and prance across the stage, and then I was going to talk about it. But y'all have all seen this on the video, so you didn't need to see it in person, right? So I apologize, but I promise you when I come back next time, if I'm invited back after this, then we'll give a great demo of the next generation of this product. So I apologize for not being able to demo this product. But I think you understand the possibilities here. I think Yuto-san did a good job of describing some of the applications that these robots can do for us. So I think the future is really, really bright. Now, I'm a technology optimist. I believe that technology can make the world a better place. That's what drives me every day, and that's what gives me the courage, like Peter talked about walking on water. Being a technology optimist is what gives me the courage to try these crazy things. So I went to school. I graduated with a computer science degree. I learned how to program in C and C++, and, well, I'm pretty old. So back then, assembly language and everything else for the various processors. And I had to think about every single error that could happen, or every single case that a program was supposed to do, just in case something went wrong for the program to recover. And that's kind of what a traditional engineer does. You all know this. You've started companies before. There's a lot of entrepreneurs in the audience. So what does the future look like? I know that the universities that are graduating people today, they're obviously still teaching C and C++, and you're still graduating with a computer science degree. But there's also machine learning. There's these neural networks that we just talked about. So who programs those, and how do they function? If a neural network is built, how do I look at it? Well, you can't look at it. It's like your brain. You can't see inside your brain and understand how data taught you when you were 3 years old how not to spill milk. You just know how to do it, right? So this completely changes computer science. We no longer have linear programming, and we now have neural networks that are trained by data. And the more data, the better. So what is an engineer? I think in 20 years, engineers are teachers. And they train our robots and our artificial intelligence clouds to do new things and to continuously do things better. And I'm really looking forward to the day when my sons can train their robot to do something completely new. That's all I had today, you guys. What I want to do is I want to open it up to questions. And I'm not exactly sure how we're going to do this, but I know that we have a staff that's going to help find the right questions, and hopefully we can have a little bit of time to answer them, okay? Thank you very much.
ありがとうございます。それでは
Thank you very much. So as was just mentioned, we would like to open the floor to any questions there may be. So if you do have a question, please raise your hand, and I would like to call upon the person that has the question. So to the right, center right, I believe it is, I see a hand.
Please go ahead.
All right. A quick question going back to your first slide with the computer technologies overlapping. Looking at that slide, it seems like AI's time is already here because you said they're overlapping. But when we read all the news about the cars or how the AI beats the Go player, it seems like we're still very far away from consumers' applications. So do you really think that AI is the next bubble and it's already starting today overlapping with mobile? Or is there something else, a 0.5 in between that needs to come first?
Yeah, it's a good question. You know, I think it's already happening. And I think it's happening in little ways, but it's in everybody's life. So Siri is a form of AI. You can ask it questions, it's going to answer. And honestly, the speech recognition engine that's driving Siri is based on a neural network. And it learned how to understand human speech. And image search on your favorite search engine, that uses AI for pattern matching. And Google Now on Android is an AI assistant that predicts what you might need next, even before you ask that question. So it's actually, a lot of it is in our lives today, including the rice cookers and everything else. But you know, we'll see it kind of come to life, I think. I don't know what it is. I don't know if it's 10 years or 20 years, but we're going to really see jumps in its capabilities pretty soon in your daily life.
それでは他に質問のある方いらっしゃいますか？一番
Are there any other questions? There's a person on the other side who raised the hands first. There's a person.
Thanks so much. And so I have a question about, so we are all in a business, right? So every platform, every business is actually becoming commoditized. So having said that, I think probably AI is going to commoditize too. And who's going to win the game? Is that the one who's going to have the biggest set of data, or is that someone actually who can actually crack the sort of how to actually cook the AI things? So,
Yep, it's a good question. I think it's hard to answer. I mean, we're all trying to have a vision and trying to predict what the future is going to be like, and it's always hard to do that. But currently, I think there's a lot of investment. If you just think of it from a venture capital perspective, there's a lot of investment in AI clouds, a lot of the machine learning that happens behind the scenes in the cloud to make some of these decisions. But I think if this ecosystem thesis comes true and AI is potentially the next platform, the only thing that's going to have kind of the flywheel effect, the only thing that actually makes it a platform is by having third parties develop components on top of it to make it do something it's never done before, right? So if you have a general compute resource in the cloud because you have a data center full of millions of machines, that's an AI platform. But the person that feeds it the data, or the team that feeds it the data, or the startup company that has a unique piece of data to make it do something completely new, that's the killer app, right? And I think there will be millions of those types of apps. And that's one of the things when I talk about training it, how it gets smarter. It does a new thing it never did before. I recently did a article for a US publication, Wired magazine. And the interviewer asked me some questions like this question. And I used an example. The example I used is a dashboard camera for your car. You put it underneath the mirror of your car, and it records video of you driving. And every now and then, it'll see an accident, right? There's a killer app just in having that. People buy these things today. But what people haven't done is take the data, take the video of you driving every day on your commute and feeding it into the cloud to make new applications, right? Some of the applications might be, it builds maps. If 10 million people have a connected dashboard camera and all that data goes into the cloud, we'll have a better map of the world, 100 times better map of the world than what we have today. It's crowdsourcing of video data. And then we can learn from that. We can learn what an accident looks like. We can learn what a lane is. We can learn what a stop sign is. We can learn what a one-way street is. And we'll just get better at it over and over again. That's the example I use. One killer app of millions. Next question.
では、前にいる方、その
There's a person in the front then.
Robot is kind of cute, but I'm getting nervous because good guys uses robot be good things, but bad guys will use robot be kind of scary things. So what do you think about that application for new technologies?
Yep, it's a good question. It's a question I actually get a lot. You know, how do we not build Skynet and lose control of the AI that we're creating? And I call these questions, no offense, these are good questions, but this is the science fiction question, right? Because we've all watched the movies, but it's never actually, it hasn't been reality yet. So we're all making judgments based on Hollywood. I watched the movie Independence Day. Has anybody watched Independence Day? It's when aliens come and they're much more powerful than we are, and we have to band together and somehow win against the aliens using some trick. I forget what the trick was. There's always some trick in these movies. How we can win against a superior race using ice or some trick. I don't know what it was. And I did an informal query. I asked about 20 people, friends and people, friends of friends. I was at a party. I asked them, if an Independence Day thing happened tomorrow, would you want the robots protecting us? If we could have robots protect us in that scenario, would you want it? And 19 out of the 20 people said yes. If the humans were at such odds against this great invading alien force, we would need some help. So in that scenario, everybody was very supportive of this technology helping us survive. And then if you ask the question in a different way, a different set of people, this time I only asked 10 people, will a robot potentially someday take away your job? Will it hurt you somehow, socially, financially, whatever else? And 10 of 10 said, yes, I'm really worried about this, right? So there's the science fiction answer, and then there's the real answer, and there's two different things. And all I can say is we're not there yet, but on the basis of everything that I know, any AI that's smart enough to do some of the things that we're talking about doing is also smart enough to know the impact of what it's doing. And we haven't gotten there yet, right? So I'm hoping that we never see these days, but it's certainly a question I get a lot. Any more? We have a couple more minutes, probably enough for 2 more questions.
あと2つほどというふうにお話がありました。
We can take perhaps 2 more questions. So on the left, on the 7th or 8th row, there's a gentleman.
Does the remarkable robot we just saw have a name? And what applications, if you could expand on possible applications that you see it doing in the future? And also, what was the overall goal of Google's shopping spree with robotics companies over the past few years? There have been rumors that it plans to divest itself of some of them. It's apparently not working out as well as it may have imagined in the past. What do you think Google is or was trying to do in terms of robotics? Thank you.
Yep. So that was a question from the press side. And I think for the first part of that question, I need to bring out Yuto-san to help answer what's the name of the robot, because obviously we want to get that right for anything that you guys might write. But for the second part, the good news is I don't work for Google anymore. I don't know what they're thinking. And they were kind enough to give us a glimpse into what the R&D lab is doing. So they allowed us to have these robots on stage. So I feel it's not really my place to comment on what they may or may not have been thinking when I was working there. But let's see if Yuto's still, I'm not even sure if Yuto-san, he might have just cleared out. I would have, but let's see.
それでは中西様、ロボットに関する質問。
Nakanishi-san, there was a question about the robot. Can you come up to the stage? Nakanishi-san? Thank you very much. In regard to the name of the robot, we haven't decided yet what their name will be. In regard to what to do in the future and what it will be used for, right now we want to use this for the sake of society. We hope that this will be a robot that will be useful to society. That's all we can say for now. Other than that, unfortunately, I can't reply to any questions about other details about Google. We'd like your understanding on that. Thank you very much. We'll take one final question.
And you want to pick? じゃあ、一番
Then the person at the very front at the center, because that person raised the hands first. The person in the center.
Hi, Andy. Nice to see you on stage. This is Yamamoto from UTech. So I have a question about Playground. Since it's global, are you willing to invest in Japanese startups? And if yes, what do they need to show you to get your money? And if you have any message to Japanese entrepreneurs and engineers?
Thank you, Ted. Ted, can you stand up for a second? Can you stand up for a second?
お立ちいただけますか?
Could you stand up?
Thank you. So by the way, you funded Shaft.
Oh, no.
But
Physios.
Okay, I'm sorry. So
from UT.
Okay, UT. I'm sorry. The answer is yes, and I already have. In my past life, obviously, when I was running robotics, I made investments and acquisitions in Japanese robotics companies. You just saw one. Will Playground Global do that? Absolutely yes. I was actually really happy to see the startup competition and some of the entrepreneurs, the Japanese entrepreneurs at the startup competition as a judge, seeing some of the stuff they're doing. A lot of the stuff was in some ways vaguely related to what we were doing here and what the topic of the talk was. So it's very vibrant, and Playground will make investments for sure, for the right opportunity. Thank you.
Fantastic. Thank you very much, Andy.
Okay, everyone, thank you for your time. Enjoy the rest of the show.